Hi, today we are going to do some limiting reagent question. Let's read the question first. The reaction of gallium metal with sulfur, so we have gallium metal with sulfur, produce gallium sulfide. So we have here gallium sulfide. If the reaction were carried out using 80 gram of gallium and 68 gram of sulfur, determine the following. So the first question asks us the balancing of a chemical equation. Okay, so let's just copy the first question. Okay, so the way we are going to do the balancing chemical equation is we first will divide it into two sides. Okay, one the reactant side, the other is the product side. And then we are going to write each of the element on both sides. So first we write gallium. We also write gallium. And we have sulfur. So on the left side, which is the reactant side, you can see we only have one gallium. So we'll just put one gallium there and one sulfur there, right? Because we only have one sulfur. Now coming to the product side, you can see there are two gallium. So you want to write two gallium, and for sulfur, you have three, right? So you want to write sulfur 3. Remember, do not put 3 here, okay? Some of my students, they do like to write S3 there. No, it's not S3. Just write S and 3. Now, balancing chemical equation means what? Means both the sides need to have the same number. So if you have gallium 1 and 2 here, that means both sides need to be the same number. So how do we figure out? So first you can see we have gallium 2 on the product side. So what we are going to do is we are going to multiply the one on the left side with 2. Okay. Now using this, we get 2 here. Okay. Next, what do we see is that we have sulfur 3 on the right side. So that means we need to multiply sulfur on the left side with 3. So we have 3 here. Okay. Then what we do, we need to write down the balanced equation here. Okay, we do not write the equals to what? No, what we write with what they were multiplied with. So gallium was multiplied with 2. So you are going to write 2 in front of gallium, while sulfur was multiplied with 3. So you want to write 3 in front of sulfur. So this is our balanced chemical equation. Okay. Now coming to the second question. So let's just copy the question first. And okay. So we had our balance equation, which was 2 gallium and 3 sulfur, right? Okay. Now the second question asks for the limiting reactant. So what is limiting reactant? Okay. So limiting reactant. Okay, to understand what is limiting reactant, first we need to what? First, we need to see this example, okay? Let's say you want to make a sandwich. And to make this sandwich, you need 2 breads and you need 1 cheese, okay? So to make this one sandwich, you need 2 bread and 1 cheese. And let's say you have 10 breads, yeah? And you have 7 cheese. So which one is the one that make you not able to produce maximum number of sandwich? Okay, so with this 10 bread, right? With this 10 bread, you can only make 5 sandwich. And with this 7 cheese, you can make 7 sandwich, right? That means you have less of breads to make enough 7 sandwich. That means the bread is your limiting reagent. Okay. So that is what we understand by limiting reagent. Now coming back to our question here. Okay, so you need to remember that in stoichiometry, the currency is your mole. Okay, currency is mole. That means what? Okay, first let's just make a table. Okay, I really like to do table in stoichiometry because that really help to make us visualize all the information. Okay, so now we have gram, right? So let's just write gram there. We have 80 gram of gallium, so let's just write 80.0 gram. And for sulfur, we have 68.0 gram sulfur. Okay, now we are given the gram, but to solve this equation, you always need to know the mole. Okay, you need to know the mole. So from the gram, you need to find your mole. How do you do that? From the gram, how do you find your mole? Okay, so we have, okay, there is, you can use it with your dimensional analysis, or if you still don't understand the dimensional analysis, you can use with a formula, which is mole equals to given gram divided by molar mass. And I hope you know how to check molar mass from periodic table. Okay, so we have the gram of gallium is 80 gram. So to find mole, we just need to do what? Take the given gram, which is 80.0 gram, divided it by the molar mass of gallium, which happens to be 69.723 gram per mole. Okay, so this is gonna give us, so we have 80 divided by 69.723. This is gonna give us 1.1474 mole. Okay, I'm not really concerned about the significant figure yet because I want to be more specific, and then at the end we will write down with the correct sig. Okay, now, okay, we got the mole of the gallium. Now do the same thing for the sulfur. What do? Take the gram of the sulfur, which happens to be 68.0 gram, divided by the molar mass of the sulfur. So if we check, the molar mass of sulfur is 32.065 gram per mole. So having this, let's put this on calculator. 68 divided by 32.065, we have 2.12092 gram per mole. Okay, some of the students, they really like to, they do this mistake. They tend to do this mistake where, okay, so we have the mole, so we're just going to choose the one that is less. But that's not how it is, isn't it? Because you can see here, if you choose the one that was less, which is cheese was 7 and breads were 10, but cheese was in our what? Limiting reagent, isn't it? The breads were limiting reagent. Why? Because we need more bread to make the one sandwich. So same thing here. You cannot just look, okay, I have the gallium, which is lesser than the sulfur, so this is my limiting reagent. No, that's not how it works. So there is a trick here, okay? If you don't want to really think much about it, there is a trick where you can just, okay, so let's write here LR, which is limiting reagent. So what do? Is you take the number of mole, which is 1.1474, divided by the coefficient, which you find out from your balancing. So that's really important, okay? Balancing was really important. Otherwise, you won't be able to solve this question. So divide that by 2, because the coefficient of gallium is 2. And same thing with the, so when we do that, what do we get? So we have 1.1474 divided by 2, we have 0.5737 mole. Doesn't matter, okay? And for the sulfur, we have what? We have 2.12069 divided by 3. Why 3? Because you can see there is 3 in the coefficient. So we do 2.12069 divided by 3. We have 0.706897. So now we choose the one that is lower. So in this case, this one is lower. So that means our gallium is the limiting reagent. Okay, now that we figure out which one is our limiting reagent, we do not use this number. Do not go and use this number that you already divide with the coefficient. No, we use the mole. Because why? Because mole is the currency. This is just to figure out which one is our limiting reagent. So we get one. Okay, this is our limiting reagent. This is not. So now, whatever our calculation is always going to be depend on this mole, not this one. Okay, why? Because gallium is our limiting reagent. Okay, now, yeah, we figured out the limiting reactant is the gallium. So here, just write gallium. Okay, now coming to the third question. Okay. So in the third question, they are asking for theoretical yield. So theoretical yield is just what? How much of the product is going to be forming if you have to just calculate it on paper, which what we are doing right now, isn't it? We are doing it on paper, so that's what we are doing. So, okay. So we are going to find the theoretical yield. So we know that, okay, we have 2, we have 3, and let's see the mole. So we have 1.1474 mole, 1.1474 mole of gallium. Why am I not writing the sulfur? Because sulfur is not important here. It's not the limiting reagent. The one that is important is the gallium. Now, theoretical yield, if they're asking you, okay, how much of gallium sulfide is going to form? That's the question here. Okay, so first, we do with a factor. Okay, so we want to find how much of gallium sulfide is going to form. So we start, okay, let's just write this GA, okay? It's gonna be way much better. Okay, so first we need to be able to cancel the GA, right? So what do? On the bottom, so we are going to choose the one from the balanced chemical equation. So we will take the 2GA and put it on the bottom. And on the top is whatever we are trying to find, because we are trying to find the how much of gallium sulfide is going to be forming. So we'll just write Ga2S3. And because there is only one, so you can just put one there. Okay, so using this, we get, okay, so that when we do that, right, we cancel the gallium, right? Let me just cancel them. We cancel the gallium, and whatever answer we're going to get, we're going to get it in mole of gallium sulfide, right? But we want it in gram. Okay, so because we want in the gram, so what we are going to do, we are going to try cancel the mole. So how do we do? Because the mole is on the top here, we're going to put on the bottom. So 1 mole on the bottom. And on the top, what we are going to do? On the top, we're going to write down the molar mass of gallium sulfide, which is Ga2S3. So you need to check through your periodic table for this, okay? So it's gonna be, so it's gonna be 235.64 gram per mole. So you can now see that the mole also get canceled. Oh, this is not per mole, just mole. That's where to put the mole. Okay, so you can see that the mole is also canceled, right? And whatever answer we're gonna get in gram of Ga2S3. Now let's just put this in our calculator. We have 1.1474 multiplied with 235.64 divided by 2. We will be getting 135.64 let's just put S19 gram. So this is, okay, because we want to have the correct sig fix, so it's gonna be 3 sig fix. So the answer is gonna be 135 gram of Ga2S3. Okay, so this is answering the theoretical yield question. Now let's see the last question. It's about the percent yield. Okay, so let's just copy this one and okay. And then paste it here. Okay. We don't need that. We already did that. Okay. Now, okay. They want the percent yield, right? So we have 2 here, 3. Okay, so when we calculate how much of gallium sulfide did we get? We got 135 gram, right? So the theoretical yield was 135 gram. But they say when they do the experiment, when they do all the experiment, they figure out that the real amount of gallium sulfide that are produced is 82 gram. Okay, so this is the experimental value or experimental yield. Okay, so our percent yield is gonna be equals to the real value or the experimental value. Okay, the real value or real yield divided by theoretical yield into 100. So here we have real value as 82.0 divided by 135 gram into 100%. So doing this as the 82 divided by 135 into 100, we get 60.7% if we are doing 3 sig fig. Okay, 60.7%, which is the percent yield. I hope you guys understand the concept behind this kind of question and will be able to solve this kind of question. Thank you so much for watching. Bye-bye.